Between March and November 2024, radio telescopes monitoring the Galactic Center detected 47 distinct signals, each lasting between 0.3 and 1.2 seconds, each separated by irregular time intervals ranging from days to weeks, and each displaying identical frequency patterns, identical polarization characteristics, and identical signal morphology down to measurement precision limits. 47 separate events spanning 8 months from a region approximately 26,000 light-years away, all producing the exact same radio signature. This isn't noise. This isn't instrumental artifact. Multiple independent observatories confirmed the detections using different receiver technologies and analysis pipelines. The signals are real. And their perfect identity, maintained across dozens of occurrences separated by vast time intervals, violates every natural radio emission mechanism we understand. Astrophysical processes produce variation. Pulsars drift. Magnetars fluctuate. Even the most stable cosmic masers show spectral evolution over time. But these 47 signals show no evolution, no drift, no variation beyond what measurement noise accounts for. They're identical, and science doesn't have an explanation that doesn't invoke either new physics or something far stranger. The discovery began with routine monitoring of Sagittarius A star, the supermassive black hole at our galaxy's center. Radio telescopes observe this region continuously because it's one of the most extreme environments in the galaxy. A 4 million solar mass black hole surrounded by hot accreting material, embedded in dense stellar populations and complex magnetic field structures. The region produces various types of radio emission, from steady background radiation to occasional flares and transient events. Automated detection algorithms flag unusual signals for human review. On March 17, 2024, one such algorithm triggered on a signal that didn't match any known source class. The signal appeared at a frequency of 1.42 gigahertz, the famous hydrogen line where neutral hydrogen atoms emit radiation. But this wasn't hydrogen emission. The spectral profile was wrong, too narrow and too stable. Natural hydrogen emission from gas clouds shows Doppler broadening from thermal motion and bulk flows. This signal had a bandwidth of less than 10 hertz, impossibly narrow for thermal emission. The signal lasted 0.87 seconds, then disappeared. Its intensity peaked at about 50 times the background noise level, strong enough to be unambiguous but not strong enough to saturate detectors or trigger multiple independent alerts immediately. The event was cataloged and filed for later analysis. Then on April 3rd, another signal appeared. Same frequency, same bandwidth, same duration, within measurement precision, same intensity profile, rising rapidly to peak, then declining symmetrically. Analysts compared the two events in detail and found them indistinguishable. Not similar. Indistinguishable. Every measured parameter matched within error bars. This coincidence prompted a deeper investigation. Archives were searched for similar events in previous years. None were found. But going forward, monitoring was intensified. Observers at multiple facilities were alerted to watch for recurrence. Before we examine each characteristic that makes these signals impossible to explain through known natural processes, make sure you're subscribed to Cosmic Outliers and notifications are turned on. This is an ongoing mystery with new detections still occurring, and we're tracking every development. Drop a comment with your theory about what could produce perfectly identical signals separated by weeks, because the possibilities range from exotic astrophysics to implications no one wants to say out loud. Over the following months, signals continued appearing. May the 12th, May 29th, June 8th, June 24th. The intervals were irregular, not periodic. No pattern emerged in the timing, but every single signal was identical to the first. Frequency, bandwidth, duration, intensity profile, polarization state, all matched. By July, when the count reached 15, the astronomical community was paying attention. Papers were in preparation. Theories were being proposed, and the debates were becoming heated. Natural astrophysical radio sources come in several categories. Pulsars emit regular pulses from rotating neutron stars. Magnetars produce bursts during magnetic field reconfigurations. Radio galaxies emit steady radiation from jets. Masers amplify specific frequencies through stimulated emission. Fast radio bursts produce millisecond duration pulses of unknown origin. Each category has characteristic signatures that allow identification. The Galactic Center signals didn't match any of them. The narrow bandwidth ruled out thermal processes. The irregular recurrence ruled out rotation-powered emission. The stability ruled out explosive or eruptive events, which should show variability. And the location, directly toward the galactic center, meant whatever produced them was either at the galactic center or precisely aligned with it from our perspective, an unlikely coincidence. Detailed analysis of the signal structure revealed additional puzzling features. The signals were circularly polarized, meaning the electric field rotated as the wave propagated. About 60% right-hand circular polarization, a specific handedness that's maintained across all 47 events. Natural synchrotron radiation from relativistic electrons in magnetic fields can produce circular polarization, but the degree of polarization varies depending on viewing angle and magnetic field structure. Maintaining exactly 60% across dozens of events requires the emission mechanism and geometry to be perfectly stable, not evolving at all over 8 months. The frequency of 1.42 gigahertz is significant. This is the 21 centimeter line of neutral hydrogen, one of the most important frequencies in radio astronomy. It's also, coincidentally or not, a frequency that any technologically capable civilization would likely monitor, because hydrogen is the most abundant element in the universe, and this transition is fundamental. The fact that these signals appear exactly at this frequency raised immediate speculation about intentional transmission, but scientists are cautious about invoking non-natural explanations. The burden of proof is enormous. Before concluding something is artificial, every possible natural explanation must be exhausted. Researchers proposed numerous astrophysical mechanisms. Perhaps the signals come from a pulsar with unusual properties, rotating at irregular intervals due to complex glitches in its crust. But pulsars are neutron stars, and neutron star physics is well understood. Irregular rotation would produce signals with varying pulse shapes due to changing viewing geometry. These signals don't vary. Perhaps a binary system with two compact objects produces periodic gravitational focusing of background radiation, but that would require extremely fine-tuned orbital parameters to produce identical signals, and the timing isn't strictly periodic anyway. Perhaps a cosmic maser experiences periodic pumping, producing bursts of coherent emission, but masers typically operate at specific molecular transition frequencies, and their output varies as the pumping conditions fluctuate. Another hypothesis involved gravitational lensing. Perhaps a compact object like a stellar mass black hole passes between Earth and a background radio source, gravitationally lensing the radiation and producing amplification events. If the source and lens have specific relative motions, amplification could recur. But lensing amplifies whatever signal is present, and the background source would need to be perfectly stable to produce identical amplified signals. Moreover, lensing predictions can be calculated. The required geometry doesn't match the observed timing. The intervals between signals would need to follow a predictable pattern based on orbital mechanics. They don't. Some researchers suggested exotic physics. Perhaps the signals are related to dark matter. The galactic center contains the highest dark matter density in our galaxy. If dark matter particles can decay or annihilate producing radio emission, perhaps specific density fluctuations trigger these events. But dark matter interactions, if they produce detectable signals at all, should create continuous background emission or follow statistical distributions. Producing discrete identical pulses requires mechanisms not present in any dark matter model. Others invoked axions, hypothetical particles that could convert to photons in strong magnetic fields. The galactic center has strong magnetic fields, but axion conversion produces specific spectral signatures that don't match observations. The possibility of artificial origin couldn't be ignored. If the signals are technological, if they're transmissions rather than natural emissions, many puzzles resolve. Technology can produce narrow bandwidth signals. Technology can maintain signal parameters precisely over time. Technology can choose specific frequencies like the hydrogen line. And technology could produce irregular timing if transmissions occur on demand rather than following natural periodicities. But invoking technology raises more questions than it answers. Who is transmitting? From where exactly? For what purpose? And why this pattern of irregular identical signals rather than something more obviously communicative? Analysis of signal content was inconclusive. If the signals encode information, it's not in simple modulation patterns that would be obvious to standard decoding techniques. The signals are essentially pure tones, constant frequency and amplitude maintained for their duration. No frequency modulation. No amplitude modulation beyond the rise and fall at start and end. No substructure detected at the limits of instrumental resolution. If they carry information, it's in aspects we haven't measured yet, perhaps in quantum properties of the electromagnetic field, or in correlations between successive pulses that require comparison across all 47 events to reveal. The scientific community remained divided. A survey of researchers studying the signals showed roughly 40% favored some not yet identified natural astrophysical process, 30% considered exotic physics like dark matter interactions or unknown plasma phenomena, 20% thought instrumental or analytical artifacts hadn't been completely ruled out, and 10% were open to considering artificial origin while emphasizing the need for much more evidence. This distribution reflects the conservative nature of science. Most researchers prefer explanations within established physics until those are definitively excluded. Efforts to localize the signal source more precisely ran into limitations. Radio telescope arrays can determine source positions through interferometry, measuring slight timing differences as signals arrive at different antennas. For strong sources, positions can be determined to millisecond precision, but these signals are relatively weak and short duration. Position measurements have uncertainties of several arcseconds, which at the galactic center's distance corresponds to tens of light years. The signals definitely originate from the galactic center region, but whether they come from Sagittarius A star itself, from the surrounding cluster of stars, or from some other structure within that region can't be determined with current data. Attempts to detect the signals at other wavelengths failed. Optical telescopes, X-ray satellites, and gamma-ray detectors were coordinated to observe the galactic center during periods when radio signals were detected. No simultaneous emission at other wavelengths was found. This rules out many high-energy processes which typically produce multi-wavelength emission. It suggests whatever produces these signals operates specifically at radio frequencies without broader electromagnetic output. Or alternatively, any emission at other wavelengths is too faint to detect with current instruments. Theoretical physicists explored whether known phenomena could produce the observed characteristics under extreme conditions. One proposal involved relativistic jets from the supermassive black hole interacting with dense molecular clouds. If the jet impacts a cloud, it could produce shock heating and magnetic field compression. Under very specific conditions, this might generate coherent radio emission, but maintaining identical conditions across multiple impact events over months requires an implausibly stable configuration. Jets vary, clouds move. The required fine-tuning seems unnatural. Another idea suggested acoustic oscillations in the accretion disk around Sagittarius A star, analogous to how sound waves in the Sun produce oscillations detectable through helioseismology. The accretion disk could support waves that modulate radio emission. But accretion disk modes evolve over time as material accretes and conditions change. Producing identical signals requires the disk to reset to identical states repeatedly. The physics for such resetting isn't clear. Researchers also considered whether the signals might be reflected or re-emitted versions of terrestrial transmissions. Earth broadcasts radio signals that propagate into space. If those signals encounter reflective structures, they could bounce back toward Earth. The galactic center is far away, making round-trip light travel time about 52,000 years, ruling out reflections from objects there. But perhaps reflections occur from interstellar plasma structures much closer, and those structures happen to lie along the line of sight to the galactic center. Detailed analysis of signal characteristics shows they don't match any terrestrial transmission patterns. The frequency is natural, not used by commercial transmitters. The bandwidth is too narrow. And the timing doesn't correlate with any terrestrial broadcast schedules. The hypothesis that gained the most traction among naturally inclined explanations involved a population of objects near the galactic center, possibly stellar remnants or compact objects in unusual orbits. If dozens of such objects exist, each might occasionally produce radio emission through some mechanism. If they all have similar properties, their emissions might be similar. The observed signals could be catching these objects during identical stages of whatever process produces emission. Statistically, if many objects are active, we'd see events irregularly as different objects flare. This explains the irregular timing and the similarity. but it requires all objects to have extraordinarily uniform properties and doesn't explain why we see exactly 47 events and then apparently stopped, with no detections in December through January despite continued monitoring. As the count reached 47 in late November 2024, something changed. No additional signals were detected through December and into January 2025. Monitoring continued with the same sensitivity and coverage, but the signals stopped. This cessation is as puzzling as the signals themselves. If a natural process was active, why would it suddenly stop? Natural processes don't have endpoints unless something changed in the source environment, but observations of the galactic center show no obvious changes. Sagittarius A star continues its normal activity. The stellar population appears unchanged. If the signals were artificial, did the transmission campaign end? Was 47 the intended total? The number itself has no obvious significance in physics or mathematics that would suggest why transmissions would stop there. Statistical analysis of the timing pattern was performed to search for hidden structure. If signals occurred randomly according to a Poisson process, the distribution of inter-arrival times would follow a specific exponential distribution. The observed intervals don't match that distribution perfectly, showing slight deviations, suggesting non-random timing. But the deviations aren't strong enough to prove deliberate structure. They could reflect observational selection effects, times when telescopes weren't observing or when interference contaminated data. Advanced time series analysis, using techniques from chaos theory and information theory, found no clear patterns. If there's a message in the timing, it's subtle. Linguistic and symbolic analysis explored whether 47 events might encode information numerically. In human culture, certain numbers have significance. But those significances are arbitrary, products of our biology and history. An alien civilization would have different symbolic associations. However, prime numbers, mathematical constants, and sequences derived from fundamental physics might be universal. 47 is a prime number. The sequence of intervals between signals contains numbers that could be interpreted various ways, but nothing jumped out as obviously meaningful. Researchers compared the timing pattern to mathematical sequences, physical constants expressed in different units, and even musical scales. No clear matches emerged. The scientific papers analyzing these signals started appearing in preprint servers in late 2024. Peer review takes time, but the urgency of the discovery pushed researchers to share results quickly. The papers present careful analysis, detailing observational methods, measurement uncertainties, and statistical significance. All conclude the signals are real astrophysical events, not artifacts. But none provide definitive explanations. Most papers end with calls for additional observations, improved localization, and monitoring at multiple wavelengths simultaneously. The astronomical community is treating this as a genuine mystery requiring sustained investigation. Public reaction has been predictably varied. Mainstream media covered the story with headlines ranging from cautious scientific interest to sensational speculation about alien signals. Social media exploded with theories, memes, and debates. Some communities convinced themselves this is first contact. Others dismissed it as overblown hype around mundane phenomena. The scientific community tried to maintain measured discourse, emphasizing uncertainty while acknowledging the genuine puzzles. But the pressure for answers is intense. The public wants to know what these signals are, and scientists are frustrated by their inability to provide clear answers. The possibility of artificial origin, while scientifically defensible to consider, comes with enormous implications that make researchers hesitant to endorse it publicly without overwhelming evidence. If the signals are technological, they represent detection of another civilization. That would be arguably the most significant discovery in human history. The implications would span science, philosophy, religion, and policy. The consequences of being wrong about such a claim are severe. False positives damage scientific credibility and cause public confusion. So researchers self-censor, avoiding definitive statements about artificial origins even when they privately consider the hypothesis plausible. This creates a gap between public speculation and scientific discourse. Efforts to detect additional information in the signals continue. High-precision timing measurements search for subtle periodicities or patterns at timescales shorter than the signal duration. Polarization analysis examines whether polarization angle changes during the pulse. Phase-coherent observations attempt to measure the electromagnetic wave's phase stability, which could reveal whether the signals are truly coherent like a laser or incoherent like thermal emission. So far, these advanced measurements haven't revealed additional structure. The signals remain frustratingly simple: pure narrow-band, stable pulses. Hypothetical scenarios about artificial origins explore what such signals might represent. If someone is transmitting, what could be the purpose? One possibility is a beacon, a signal designed to be detectable across interstellar distances, announcing presence to anyone watching. Beacons would be repetitive, long duration, and use naturally significant frequencies. The 21-centimeter line fits. But why irregular timing? Perhaps transmissions occur on schedule from the transmitter's perspective, and what we perceive as irregular timing results from relativistic effects, gravitational time dilation near the black hole, or signal propagation through complex space-time. Another possibility is communication not intended for us. Perhaps we're eavesdropping on transmissions between locations in the galactic center region, or between the galactic center and somewhere else, and we happen to lie along the signal path. The cessation of signals in December complicates interpretation. If artificial, did the transmitters stop intentionally? Was the message complete after 47 pulses, or did something happen to the transmitter? If natural, what changed in the source environment to halt the process? Could it resume? Monitoring continues because if signals restart, the pattern of resumption could provide crucial clues. A long hiatus followed by resumption would suggest periodic activity with a timescale longer than months. Permanent cessation would suggest a finite process that completed. Alternative explanations invoking unknown physics remain possibilities. The universe has surprised us before with phenomena that weren't anticipated by theory. Pulsars weren't predicted before their discovery. Fast radio bursts were unexpected. Black hole mergers detectable by gravitational waves required technological advances to observe, but weren't fundamentally mysterious once detected. Perhaps these galactic center signals represent some new category of astrophysical transient that will make sense once we understand the underlying mechanism. History suggests humility. Many astronomical mysteries that seemed inscrutable were eventually explained by natural processes, often mundane in retrospect. But history also contains examples where simplicity and Occam's razor point toward less conventional explanations that were initially resisted. When quasars were discovered, their properties were so extreme that some researchers suggested non-natural origins before the black hole accretion model was developed. The lesson is complex. Sometimes exotic explanations are correct. Sometimes conventional science prevails. Determining which applies requires evidence, not philosophy. For the galactic center signals, evidence remains insufficient for definitive conclusions. That's intellectually honest, but publicly unsatisfying. The infrastructure for continued monitoring is in place. Radio telescopes continue observing the galactic center with sufficient sensitivity to detect signals like those seen in 2024. If they resume, we'll know immediately. If they don't, the mystery will persist until either we understand what natural process produced exactly 47 events then stopped, or we conclude, through elimination of alternatives, that artificial origin becomes the most parsimonious explanation by default. Neither outcome seems imminent. This mystery will likely remain unresolved for years, possibly decades, until technology improves or serendipitous additional observations provide new insights. The broader implications about our place in the universe hover over this discussion. If the signals are natural, they teach us about astrophysics in extreme environments. Valuable, but not transformative. If they're artificial, they confirm we're not alone. That confirmation would reframe humanity's self-understanding. We would be one civilization among potentially many. Questions about communication, contact, risk, and opportunity would move from speculation to urgency. Governments, institutions, and individuals would need to grapple with practical implications of a cosmos populated by intelligence. The fact that we don't know which scenario applies creates tension. We're suspended between two radically different universes, one familiar and lonely, the other crowded and uncertain. For now, the data is what it is. 47 signals, identical characteristics, irregular timing, galactic center location. No explanation that comfortably fits all observations. Science proceeds by accumulating observations, testing hypotheses, and refining understanding. This case is early in that process. The observations are documented. Hypotheses are proliferating. Testing has begun but is incomplete. In time, with more data, with better instruments, with innovative theoretical insights, an answer will emerge. Or perhaps the mystery will deepen. Perhaps we'll detect similar signals from other directions, revealing a widespread phenomenon. Perhaps we'll never see them again, and the 2024 Galactic Center signals will become an astronomical footnote, an unsolved curiosity that future generations puzzle over. The human response to mystery reveals our nature. Some embrace uncertainty, finding beauty in questions without answers. Others demand resolution, uncomfortable with ambiguity. Science navigates between these impulses. Scientists must be comfortable with uncertainty to do their work, yet driven by desire for understanding to persist through difficulties. The Galactic Center signals test that balance. They're mysterious enough to be fascinating, concrete enough to be scientifically tractable, yet resistant enough to explanation to frustrate progress. That combination makes them perfect emblems of the scientific endeavor itself, wrestling with nature's puzzles using reason and observation, never certain where the path leads but committed to following it wherever it goes. If this investigation into the 47 identical signals from the heart of our galaxy captured your imagination, hit that like button and subscribe to Cosmic Outliers for updates as this mystery continues to unfold. We're monitoring for any new developments and will report immediately if signals resume. Drop a comment with your best theory about what could produce perfectly identical radio signals, separated by irregular intervals, because this is one of those rare moments when we genuinely don't know what we're looking at. The universe just presented us with a puzzle that challenges everything we thought we understood about the Galactic Center, and solving it might change our cosmic perspective forever.